Thank you again for inviting me. So I'm going to talk a little bit about engineering in general, not specifically about Marshall Space Flight Center. So I hope you enjoyed your technical fix. I really did, Shannon. That was really, really entertaining. And I appreciated that you didn't use too many big equations. It's been a few years since I was in math. But what I really wanted to talk about is the importance of the science, technology, engineering, and math field for us as a country and as a nation. And that it is no easy path. It's full of requires a lot of commitment and a lot of hard work. And I got just a quick shot of a couple of guys, George Washington Carver and Thomas Edison, both of who had really good quotes. And I don't know why the quotes aren't showing up on my slide. But Carver said, you know, no achievement comes without hard work and knowing your business and knowing it down to the detail. He said, veneer is worthless. And so the point is that you really got to have your roots deeply embedded in the tools that you're being taught in school, first and foremost. So even though you may not appreciate numerical methods or thermodynamics or circuits or fluids, depending on what field you actually eventually end up in, you need those diverse sets of tools to be able to create a future that these gentlemen actually were able to do. Edison said that there's a whole lot of opportunities that are missed because they are dressed in overalls and look like hard work. So I think that kind of tells the tale. That's why this room is not full of 50 people. This is hard work. When I graduated, I had worked really hard, had good grades, but grades weren't enough. When I got my interview, the questions were, you know, the grades basically got you over the first gate. So grades are critical. Being able to know the tools is good. But to get through the next gate, they want to see that you got the tenacity to do the job. And I had worked a lot of construction in my you know, to get through college, and I had a few jobs that were 60 and 80-hour-a-week jobs, and because you know you got to make the money when it's ready. And that's what the German gentleman that called me about my interview, he asked me, dude, Chris, you really work 80 hours a week? I said, yes, sir. He said, good. And off we went. So it wasn't the grades. It was what they were really looking for was somebody that had the demonstrated ability to get in and drive hard. So I felt pretty proud about that. Worked really hard to get there. Which way do I want? Oh, there it is. The quotes are there. And here I go. I'm right out of college, and I'm excited about having made this successful transition to the workplace. And you might tell that this is pretty old, but you know, there's a smoking discouraged sign up there in the corner.
What is that machine there on the
That's the high technology. Of course, this was before laptop computers. Weren't even heard of laptop computers. There was one mainframe. Card decks for making your code, and that's a telephone there. That's a new one, and all of our desk phones were those old black, you know, handheld devices with the rotary dial. So, yeah, it's showing my age a little bit. Cell phones? Are you kidding? You know, tweets. I'm so glad we're tweeting. But social networking was talking with your colleagues face to face and or getting on the phone. But the point I wanted to make was getting here and getting out of school did take that work, and even though I was really proud of all of my efforts, I didn't get there without a lot of help. And I mean, teachers that pulled me out of the ditch many times, that made bail for me once. You know, you get a lot of help on your way to one of these things. So it takes both your tenacity as well as good people supporting you and moving you along. And so we're talking about the world and how connected it is, and this is one of my favorite shots of looking at the U.S. At night and seeing all of the big cities, the small places, et cetera. And yeah, we're all pretty well connected. You know, the world is getting smaller and smaller all the time. But it probably doesn't take much to upset that dynamic. You know, one big coronal mass ejecta several years ago took down the Northeast, took out quite a bit of the grid. And so while it is, we feel pretty comfortable in our connectivity, it can be very short-lived. And the world is quite dynamic, as we know. We don't think about it very often, but it's continually changing. Just last week, I guess, you know, we got a little reminder of how quickly it can change. I can't imagine being actually in Russia when that huge explosion occurred overhead and wondered what the heck happened. You know, are we under attack? But I just got a comparison. The two meteorites were about the same size, about 45 to 50 meters. And this is the one that's in the crater that is actually in Arizona. And I was actually there 2 years ago, first time I'd ever seen it. Anyway, we live in a dynamic, ever-changing, and it can turn on a dime. So as engineers, we really like to, you know, we watch the world, we watch the processes, and we think we can, you know, get out there and improve them and make them better. Things to help mankind, from bridges to power plants, to rocket systems. We've been evolving these skills. You know, engineers really like to take knowledge, apply it, see how it does, and create some rules around it, and then do it again. We feel pretty confident. The community that uses all of the things that we create, they really love it. They don't care so much about the math. They really like the fact that it works. When it doesn't work, they get kind of upset. They don't really want to know why it doesn't work. They just want it fixed. It's kind of a sad state that the country is to the place where science and technology is so misunderstood, or so little understood. And I kind of blame ourselves. We have to dumb down the things to a third grade level. We talk about that all the time. We shouldn't be dumbing it down. We should be bringing our parents, bringing our colleagues, bringing them up to a level. And they actually appreciate it when you do. You know, if you can do it without all of the math, give them some analogies, they really appreciate understanding a little bit about the technology. But there is one time when they really care about it, when they wonder about the fact that we thought you guys were so smart. We were really really impressed. So, you know, this is an old picture. Many classes get to use this, but that's the Tacoma Narrows Bridge, Galloping Gertie, as it was called, which had a structural instability that got set up by the wind blowing. Now, this is 1940s, so, you know, we're way smarter than that now. We understand all that stuff. That would never happen today. And sure enough, in 2007, not the same type of failure, but just as significant in Minnesota, or was it Michigan? It was Minneapolis. You know, quite a few people killed, a bridge collapse, generated a lot of additional analyses about what's going on in our infrastructure. But the point is, we're still always learning about what we're creating. We don't actually know the limits or the edges of what we're building with the new technologies and new materials, et cetera. In my side of the business, working, I got the pleasure of coming to NASA and work on high power systems. Get pretty excited about them. But there were days when it didn't work out so well. This little thing laying down there in the flame bucket was supposed to be up there in the test stand. And this was out in California, one of our test stands. A small detail and a big problem. Had a little crack, little leak that progressed over a few seconds, and a few milliseconds later, that engine gutted itself. Sometimes we call it aggressive disassembly, explosive disassembly, hardware-rich operation, quite a few holes in the hardware. But this is actually when we find out what we don't know. All of us have had lots of success. And that really, you don't learn anything from your success. You kind of learn what you already knew. Didn't feel it so much. When you have a failure, you learn what you didn't know. You find out the limits and the edges and the tolerances and how they stack up and how those little minor decisions you made when you were doing that design trade coupled together with another decision to create a problem. And that's really the challenge in our business is maintaining a level of curiosity and open-mindedness about our hardware and always questioning our own decisions. And in this business, when we have a really bad day, it gets all over the news, rightfully so. And it can be a very, very, we had presidential commissions. They were more than investigations. They were very, very difficult. I was actually on the console for Challenger in 1986, and that really surprised all of us. The fact, first of all, that it was a solid rocket booster that failed surprised us all. My friend from Pratt & Whitney's here, and most everybody would have expected that that explosion to have been a Space Shuttle main engine with all of its 6 billion intricate parts and operating with horsepower ratios of 100 horsepower per pound of engine, really high power density. But no, it was a solid rocket motor. And then again in 2003 when Columbia happened, totally different type of system. Again, something completely unexpected. A piece of foam weighs slightly more than air. You've worked with heavy foam. This is really light foam. There's 4,000 pounds of this foam on that external tank, and it only weighs 2 pounds a cubic foot. So a piece of really lightweight foam to take down a 200,000 pound aircraft. The bigger lesson beyond the design issues and the shortcomings in the design was a failure in what I call our curiosity. People talk about complacency getting into systems when you have lots of success and you know things go along. I guarantee you there's not a person that worked this program that was complacent. But what does happen is over time, your successes will simplify the system. When we have little anomalies, we make simplifying solutions to make a decision. And over time, those simplifying solutions simplify the system in your head. And so what happens is our mental models get simpler, and then you don't realize that some decision is going to cause a problem. So foam was a maintenance issue. Not so. So what does it take? How do we do both? Because we're going to have, if we're going to do anything, if we're going to get out and beyond our own footprints, if we're going to not succumb to what most systems do when they have a failure, which is control and order and limit the opportunities for uncertainty, that is a death walk. That will terminate anywhere we're going. There is no possibility, there is no future if there's not some uncertainty. If you can't ask a question, if you can't be curious and see those uncertainties, then there is no possibility that's different than where you are. So what do we do? So I got a little analogy around the engine of possibility. So I'm going to try this out with you guys. This is the first time now. And so being a propulsion guy, I decided engine was the right thing to do. And I decided that an engine, I'm going to break it into 3 parts. The drivetrain, the resistance eliminator, so a lubrication, and a fuel. In the drivetrain, I'm gonna go is our courage. You got to have undaunted courage to be a hard-charging engineer, because it is really it is a challenge every day. People are going to be telling you you can't do this, and they don't understand why you want to do that, and you're going to have to lean out the window and be able to take a risk, and that takes a lot of courage, because you really don't actually know all the answers like we'd like to think. So the drivetrain is courage. I'm convinced that the lubricant that makes it all work is humility. And what I mean by that is the ability to know that you don't know, the ability to admit mistakes, the ability to listen as opposed to talk. And I know I'm doing the talking, but the fact is teamwork and knowing how to listen to people is critical in the complex systems that this nation has grown to love. And then the fuel for this machine is curiosity. And I'm talking about that childlike curiosity that the good book talks about. We really got to maintain our curiosity. You see the problems it can lead to over time. And I really appreciate our young folks, because they ask why. They ask why when they come into the office, and half of us have forgotten why we did something, and that's when we're in danger. So we really need our youth to be picking this mantra up and coming into the workplace. And I threw Elijah in there because he did create that oiler for the locomotive engines. That's where they come up with the term the real McCoy. So back before he was there, people were running alongside the locomotives to squirt oil on all the little moving parts. And so he was a game changer right there. So if this country wants to continue on its leadership, it's got to keep its heart and its spirit and its eyes looking up. We have, as a country, done tremendous things, unheard of things. There's a 100-ton space station flying around with 6 astronauts up there right now. Today, we depend on the Russians to get us back and forth. We've got a couple of programs in work with a commercial crew that should bring us new capability in about 3 or 4 years, and a space launch system that's going to take us beyond station. But for the time being, we are dependent on our international partners. Neil deGrasse Tyson, in a recent interview, was quoted as saying, you know, all we spend today on our exploration initiative is 0.5%. And we get so much bang for that buck in everything we do. And by the way, you know, someone told me one time, when I was growing up, I thought, why are we wasting all this money going to the moon? Why aren't we fixing the problems here? Well, somebody eventually told me there's no bank on the moon. There is no money going to the moon. That money is all in this community. And not to mention the technology that it created, the machine that became for this country. There's others that are going to do it, whether we do it or not. The Chinese have made huge strides in their manned spaceflight program. They recently were able to demonstrate on-orbit docking with a module, and they've had at least 2 missions bringing humans to and from space. The last one was piloted by a female. So whether we do or don't, they will. So I'm convinced that as a country, we have the capacity and the capability and the will. I think we need the community and the students who are equally as passionate about it to get us moving there. It takes a big village of people, and it takes them all pulling and thinking and working together. And that's some of the things I'm hoping you're learning here at this institution, and that at my career, at my point in my career, I'm to the place of not trying to do any more design. I just want to pay it forward and tee up the next opportunity for you guys, so that someday we can be up here taking pictures again of that blue marble back here where we live. So thank you. That's the end of my pitch, and I appreciate your time.